and I'm going to demonstrate to you that within the uncertainty of the measurements, that I get the same numbers in all three cases, within the uncertainty. So, if you're ready for that, you see here the timer, all of you can see, and here you see the pendulum, and I have two marks on the floor here. If I hold the bob here, then it is 5 degrees, this is 5 degrees, and when I hold the bob here, it is 10 degrees. Timing is not easy. The best way to do it is to start the timing when the pendulum comes to a stop. That is rather well defined. And then you let it swing 10 times, and then when it comes to a stop, you stop it. And it would help me if you would count how many oscillations we have made. Because then I don't have to look at it. All I have to do is when I come close to 10, I have to watch for the moment of stopping, and then I will end it. So, we'll do this first at 5 degrees. I'm going to start it when it comes here. Yeah! Okay, now you count. You're doing very well. You're going to pass this course. 45.7, so that becomes that t, that means this whole equation now has to be divided by 10. And now you will see why I measure 10 oscillations. So t is going to be 4.57 plus or minus 0.2 divided by 10, that is plus or minus 0.02 seconds. And you see, comfortably within the prediction. So maybe my reaction time is a little better than 0.2 of a second. Don't count on it because you haven't seen the rest yet. So, now 10 degrees. That moment is crucial. That moment is crucial. That's where you can lose 0.4 of a second, and then you look like an idiot in front of your students. Now comes the hardest part. The hardest part is that we have to change the mass of this object. And the way that I'm going to do that is prominently demonstrated on the cover of my book. Yes, I'm going to hang on that pendulum. It is a difficult demonstration. First of all, it is painful. It really is. Second, the timing is tricky. Because when you look at the pendulum and when you see it stand still, you know, that is really well defined, plus or minus 0.1 seconds. When you are swinging yourself, however, then you can only do it by sensing the moment that you think you stand still. And that's what I will do. And then you will do the counting. And this is very unpleasant. It is. Oh, there's something else I haven't told you. If you're a good physicist, you will say, if you're going to sit on that bulb, then effectively you bring the mass of the bulb up, and so the length of the pendulum will shorten, and so you get a shorter period. And I know that too. Therefore, I will have to stretch my body so that when it is here, that it is almost completely parallel to the floor. If I don't do that, I will not be able to convince you that the period is independent of the mass. And that makes it very difficult for me. So I will start it at some moment, you will see when, and then you do the counting. Are you ready? Okay. Yeah! You count. This happens sometimes. And in fact, nobody knows why. Have to start all over. I did not stop it, I really didn't. Oh, it's still counting? Okay, I have enough energy to give it one more attempt, but not to give it two more attempts. Okay. You ready? Okay. Oh, this really hurts. Can't you count a little faster? T with Walter Lewin. What is it? 45.9 plus or minus 0.2. Period is 4.59 plus or minus 0.02. I told you, physics works.